Alright, so we're going to have a look at another question from the 2020 HSC Standard 2 Maths paper. So this is question 30. So this is a flow diagrams question. So we're given a network diagram. This is a flow diagram. It's got directions on it. A series of water channels and ponds in a garden. The vertices represent 6 ponds. The edges represent the water channels connecting them. The numbers on the edges indicate the maximum capacity of the channels. We need to determine the maximum flow of the network. So we're actually going to draw this quickly. So we have A, B, D, E, C, and F, and then we need to connect these. So this one is 200. This one is 150. This one is 50. This one is 125. This is 75. We've got one going sort of backwards up this way. This is 50. One going up here. This is 100. This one is 50. This one is 300. And the one coming in is 350. And then the one going out is 350. So the question asks us, part A, anyway, asks us to determine the maximum flow of the network. Okay, so one thing you've got to remember, max flow equals min cut. So we need to do a whole bunch of cuts, find their values, and whatever the lowest value of any possible cut is, will be the maximum flow. Now, the most basic way to do this, because this is a relatively simple diagram, is just to draw a whole heap of different cuts that pass through the diagram, calculate their values, pick the lowest one. If you do enough of them, you'll get the minimum cut. The value of that minimum cut will be the maximum flow. So let's draw a few. Let's change color. Let's change to orange. So we might have one here. We might have one like this. We might have one down here, and then we might have one here. So we'll call these 1, 2, 3, and 4. And then we'll add these up. So 1 has 200 going through it and 150 going through it, so it's 350. 2 has 50 going through it, 75 going through it, and 200 going through it. The 50 going backwards does not count. So anything going this way doesn't count. It has to be going from left to right. So 200 plus 75 plus 50, that's 325. Cut 3, we go through 50 and then 75 and then 100 and then 50. So 50 plus 50 is 100 plus 100 is 200 plus 75 is 275. And then cut 4, IV, is 300 and then 50. This is 350. So of the 4 we've chosen here, cut 3, 275, is the lowest. And so this is likely to be the maximum flow. And in fact, this is the maximum flow. So of all of the cuts we could pick, this is the minimum cut. And therefore 275 is the maximum flow. Because this is a relatively simple diagram, you can just pick a few and try them. Right? So that's actually quite a good strategy in these types of questions because it's fairly fast. Now for part B, we're told a cut is added to the network as shown. Is the cut shown a minimum cut? Well, we know the minimum cut is the maximum flow. Right? This is a piece of information that we've burnt into our memories. So 275 is the max flow, therefore 275 is the min cut. If we look at the cut listed, it goes through 50, 75, and 200. So it's actually cut number 2 up in our top diagram here. 50, 75, 50 backwards, and then 200. It has a flow, it has a cut value of 325. So is the cut shown a minimum? No. No. 325 is greater than 275. Therefore, the cut is not a min. It is not a minimum cut. And this is the answer to part B. In terms of our marking, you'll get 1 mark for identifying a cut or equivalent merit. So drawing some cuts, finding some values, they'll give you a working mark for this. They want you to get marks for trying to do this because it's demonstrative of knowledge if you can produce cuts in a diagram like this. For the second mark, you will need the maximum flow. So you'll need the minimum cut value, thus the maximum flow. And for the second part, you need to get the correct solution. So you just have to be able to say the weight of that cut or the value of that cut is 325. 325 is greater than the maximum flow, therefore it is not a minimum cut. So this is how this question works. These questions look very intimidating when students see them. But if you've learned how to do flow rates and cuts in class, this is a pretty straightforward question, especially if you're using guess and check, right? If you were formally instructed in an algorithm for this, it can be much harder, right? Doing algorithms to find official minimum cuts, stuff like that, Dijkstra style algorithms, they can be quite lengthy, right? This can take ages, but because these diagrams are fairly small and because it's not worth many marks, it's a fairly quick question. Picking a few that seem to be the lowest is not a bad way to go, right? And this works really well in this question. It means you can get this question done very quickly within the exam.